Hey there, tech enthusiasts. Welcome back to another deep dive into the fascinating world of technology. Today we're going to shine a spotlight on a component that often goes unnoticed but plays a crucial role in our digital experiences. Today, we're diving into the world of GPUs, those powerful chips that make our digital lives more vibrant and immersive. Whether you're a gamer, a designer, or just someone who loves watching high-definition videos, GPUs are working tirelessly to enhance your experience. You might not see them tucked away inside your gaming rig or laptop, but trust me, they're working tirelessly behind the scenes. These little powerhouses are responsible for rendering the stunning visuals you see on your screen, making sure everything runs smoothly and looks amazing. From rendering breathtaking landscapes in video games to crunching massive datasets for AI, GPUs have become the unsung heroes of the modern technological landscape. They are the silent workhorses that make it possible for us to enjoy seamless and immersive digital experiences. But how do these magical silicon wonders actually work? What goes on inside these chips that allows them to perform such complex tasks with ease? Let's take a closer look at the inner workings of a GPU. What makes them so different from the CPUs we always hear about? While CPUs are designed to handle a wide range of tasks, GPUs are specialized for parallel processing, which means they can handle many tasks simultaneously. This makes them incredibly efficient for tasks that require a lot of calculations, like rendering graphics or processing large amounts of data. And just how many calculations can they actually perform in a single second? The answer is mind-boggling. Modern GPUs can perform trillions of calculations per second, making them some of the most powerful computing devices on the planet. Buckle up, because we're about to unravel the mysteries of the GPU and explore its incredible power. We'll delve into the technology that makes these chips so fast and efficient. And we'll see how they're being used in everything from gaming to scientific research. Get ready for a wild ride through the world of parallel processing, teraflops, and the mind-boggling speeds at which these tiny chips operate. By the end of this journey, you'll have a newfound appreciation for the unsung heroes of technology that make our digital lives possible. Hold on to your hats, folks, because we're talking serious numbers here. Modern GPUs are capable of performing trillions of calculations per second. Yeah, you heard me right, trillions. To put that into perspective, imagine a single GPU doing the work of millions of those old-school calculators simultaneously. It's mind-blowing. Back in the day, a gaming console like the Nintendo 64 could handle a few million calculations per second. Fast forward to a few years ago, and a decent gaming PC was already crunching billions. But today's top-tier GPUs, they're in a whole other league, effortlessly hitting the 30 trillion mark and beyond. It's like comparing a snail to a supersonic jet. The difference in speed and power is just astronomical. Now, you might be wondering, what's the difference between a CPU and a GPU? Aren't they both just computer chips that do calculations? Well, yes and no. Think of it this way: the CPU is like a highly skilled chef capable of handling a variety of complex recipes with precision. It's got a few powerful cores that can juggle multiple tasks at once. The GPU, on the other hand, is like a massive team of line cooks, each specialized in a specific simple task. They might not be individually as skilled as the chef, but they make up for it with sheer numbers. GPUs pack thousands of smaller cores, all working in parallel to process massive amounts of data simultaneously. And when it comes to tasks like rendering graphics or running AI algorithms, that parallel processing power is an absolute game changer. Let's dive deeper into the specifics. The CPU, or central processing unit, is often referred to as the brain of the computer. It's designed to handle a wide range of tasks, from running your operating system to executing complex calculations. CPUs are optimized for single-threaded performance, meaning they excel at tasks that require a lot of processing power from a few cores. Imagine a chef in a kitchen meticulously preparing a gourmet dish. The chef can handle multiple ingredients and steps, ensuring each part of the dish is perfect. This is akin to how a CPU operates, managing various tasks with precision and efficiency. CPUs typically have a few powerful cores, each capable of handling different tasks. These cores can switch between tasks quickly, making them ideal for running complex applications and multitasking. Now let's shift our focus to the GPU, or Graphics Processing Unit. unlike the CPU, the GPU is designed for parallel processing. Think of it as a bustling restaurant kitchen with many line cooks, each responsible for a specific task. While each cook may not be as versatile as the head chef, together they can prepare a large number of dishes simultaneously. This specialization allows GPUs to excel at tasks that can be broken down into smaller parallel operations. For example, rendering graphics for video games or processing large datasets for machine learning algorithms. GPUs contain thousands of smaller cores, each working on a tiny piece of the puzzle. This massive parallelism enables them to handle tasks that require processing vast amounts of data at once, such as rendering complex 3D graphics or running deep learning models. In summary, while both CPUs and GPUs are essential components of modern computing, they serve different purposes. The CPU is like a master chef, handling a variety of tasks with precision, while the GPU is like a team of line cooks, excelling at parallel processing. Together they create a powerful combination that drives the performance of today's computers, enabling everything from everyday tasks to cutting-edge applications in gaming and artificial intelligence. Section 4, Unmasking the GPU, a look inside. So what's going on under the hood of a GPU? Let's break it down. The GPU, or Graphics Processing Unit, is a marvel of modern engineering. It's designed to handle complex calculations at incredible speeds, making it essential for everything from gaming to scientific research. But how does it achieve this? Let's dive deeper. At the heart of it all is the GPU die, a tiny chip packed with billions of transistors. These transistors are the fundamental building blocks of the GPU, switching on and off to perform calculations. The sheer number of transistors allows the GPU to process vast amounts of data simultaneously. This die is divided into smaller units called streaming multiprocessors, or SMS. Each SM is a powerhouse in its own right, capable of handling multiple tasks at once. The architecture of the GPU is designed to maximize efficiency, ensuring that every part of the chip is utilized to its fullest potential. Each SM contains a bunch of CUDA cores. These cores are the primary workhorses of the GPU, executing the bulk of the calculations. CUDA cores are designed to handle parallel processing, meaning they can perform many operations simultaneously, which is crucial for tasks like rendering graphics or running complex simulations. These CUDA cores are the workhorses of the GPU, handling the bulk of the calculations. But wait, there's more. The GPU is not just about raw power, it's also about versatility. Modern GPUs are equipped with specialized cores that enhance their capabilities even further. Modern GPUs also include specialized cores like tensor cores. These cores are designed specifically for AI and machine learning tasks. Tensor cores can perform complex mathematical operations, such as matrix multiplications at lightning speed. This makes them ideal for training and running neural networks, which are the backbone of many AI applications, designed specifically for AI and machine learning tasks. With the rise of AI, these specialized cores have become increasingly important. They enable the GPU to handle tasks that were previously impossible or would have taken much longer to complete. These cores can perform matrix multiplications at lightning speed, making them ideal for training and running neural networks. This capability is crucial for applications like image recognition, natural language processing, and autonomous driving, where large amounts of data need to be processed quickly and accurately, making them ideal for training and running neural networks. The impact of tensor cores on AI research and development cannot be overstated. They have accelerated the pace of innovation, allowing researchers to experiment with more complex models and algorithms. And then there are ray tracing cores. These specialized cores simulate the way light behaves in the real world. By tracing the path of light rays as they interact with surfaces, ray tracing cores can create incredibly realistic lighting and reflections. This technology has revolutionized the gaming and film industries, bringing a new level of realism to visual effects, which simulate the way light behaves in the real world. Ray tracing is a computationally intensive process, but with dedicated ray tracing cores, GPUs can handle it efficiently. This allows for real-time ray tracing in games, providing stunning visuals that were previously only possible in pre-rendered scenes, to create incredibly realistic lighting and reflections in games and movies. The advancements in GPU technology have opened up new possibilities for creators, enabling them to push the boundaries of what's possible in digital art and entertainment. From the tiniest transistor to the most complex core, every part of the GPU works together to deliver unparalleled performance and versatility. Section 5. The art of chip binning, from flaws to features. Here's a fun fact. Not all GPUs are created equal, even if they come from the same manufacturing batch. That's because of a process called chip binning. You see, during manufacturing, tiny imperfections can occur on the silicon wafer, affecting the performance of individual chips. To account for this, manufacturers test the chips and sort them based on their quality. The best chips with the fewest flaws are used for high-end GPUs like the RTX 3090. Chips with minor imperfections might end up as RTX 3080s, while those with more significant flaws are either discarded or used in lower-tier models. It's a fascinating example of how even the tiniest imperfections can have a big impact on the final product.